Hey, this is Turgeon, and I'm going to teach you about free fall. When you think about free fall, you probably picture something being dropped, and that's true, that is free fall. But we're going to learn another definition. I'm going to let you all decide what you think the entry number is. Today's the 17th of the year 2017. In other years, you might be watching this, and it's not the 17th, but put the current date if you're taking an official classroom entry. Free fall means that an object is in the air. Okay, true. Oh, and don't forget, you can pause this anytime, no big deal. It also means an object has only one force on it, and that is the force of gravity, also known as the object's weight. I would write that too, the weight of the object. The mass and weight have no effect on the acceleration. This object is going to accelerate, and the mass and weight have no effect on that, which is kind of weird, you'll see. Acceleration is always 10 meters per second squared down on the Earth. On the Moon, that would be less. But here on Earth, the acceleration is constant. So the velocity is going to change, but the acceleration is constant. Go ahead and pause that, and then we'll move on to the next entry. Okay, next entry. You decide on the number of the entry. I'm calling this a free fall diagram. We're going to look at the time and the velocity and the acceleration of an object in free fall. Let's look at a baseball. Baseball starts from rest in this case. Somebody probably dropped it. So then it moves a little bit. Then it picks up speed, so it moves a little faster. And faster still. So what happens is we're looking at different times. This baseball is after 0 seconds. This is after 1 second. This is after 2 seconds. And this is, I'm going to say it fell for 3 seconds and it's about to hit the water. Let's look at the velocity. There's no velocity in the beginning because you just dropped it. And there's a velocity in the next one. Then it goes a little faster, so that represents the velocity. Then it goes really fast at the end. Again, this is right before it hits the water. Dropping this baseball into water, I guess. I don't know if you can see this arrow. I'll make this a little thicker. Now let's look at the velocities. The velocity, because the acceleration is 10 meters per second squared, that means the velocity increases at a constant rate. So the velocity is going to grow. It's going to start at 0 meters per second in the beginning, right here. Then it's going to grow to 10 meters per second. Then it's going to be going 20 meters per second. Then 30 meters per second. That's how objects behave on Earth when you drop them, honestly. Let's look at the acceleration. As soon as you let it go, it's accelerating at 10 meters per second squared because it's about to experience a change in velocity. Then 1 second later, it's still accelerating at 10 meters per second squared because it's under the same influence of the same Earth and the same gravity. Then it's still accelerating at 10 meters per second squared. I just wrote it a little differently. Then at the end, it's still accelerating at 10 meters per second squared right before it hits the water. The acceleration is constant. I'm about to go on to the next slide, so you probably want to pause it. Okay, next slide. Let's look at acceleration and free fall as kind of like a word problem, but we're going to make a table. Again, figure out the entry, figure out the date. If we're making a table of time and velocity, let's put time here. Let's put velocity here. And as usual, you should have units. Think about the units for a second. Yep, the units are seconds. Think about the units here. Yep, meters per second. We always start with 0 times. 0, 1, 2, 3, 4, 5. And you gotta think, wait a second. They didn't tell me the acceleration. But you're supposed to know that the acceleration is 10 meters per second per second. It starts from rest because it was dropped. Then after 1 second, it's going 10 meters per second. 20 meters per second. the velocity is changing at a very specific rate. That's acceleration, folks, and that's free fall, folks.